All right, let me know when you can see my screen.
Yes, perfect, thank you.
Excellent. All right, so again, my name is Michael Taylor. I'm a principal technical leader with the Electric Power Research Institute. Been here for about 4 years, and I own everything integrated monitoring and diagnostics in nuclear. Before coming to EPRI, I was the operations manager and then project manager for Luminance Power Optimization Center. And before that, a senior reactor operator at Dresden's, or Exelon's Dresden station. So this is a topic on EPRI M&D program best practices. And this is a lot of theory with just a little bit of practice at the end. So when I came to EPRI and started looking at other M&D programs, what I found was we did really great at about the first 5 of the focus areas of M&D programs. And I'm specifically using the word program versus center because not all monitoring diagnostics programs are centralized. So, we do really well with, getting and installing sensors with infrastructure, data repository, cybersecurity, and data analytics, which we're going to go through in detail. But I think where we fall short, for the most part, is in the decision-making process and the workflow, and we'll get into that. Plus, the business aspect, right? We're really running a business. The M&D program is run almost like its own entity. We may be part of the team, we may not be part of the team, but we need to be run as an entity that secures itself, that pays for itself. So let's get into it. All right, sensors. I just had a conversation 2 days ago with a gentleman from another plant, and we were talking about, we're brand new, where do we start? And my advice was, don't start at sensors. That's where most people start. They look at, okay, where do we need to add sensors? What kind of data do we need? How do we get the data in? Don't start there. Look at the end and then work back to sensors, right? There are really 3 main outputs of an M&D center, 3 main things that you can get from an M&D program. You have efficiency gains, and it could be thermal efficiency, it could be operating efficiency, it could be maintenance task efficiency. There's catastrophic failure avoidance, which is obvious. And then really with catastrophic failure avoidance, what we're finding is that most companies aren't allowing the M&D programs to take credit for the catastrophic failure avoidance. And then the third is eliminating time-based maintenance, moving from time-based to condition-based maintenance, where your M&D program is really a central part of moving from time-based to condition-based maintenance. So when we talk about sensors, what are you using to base your choices on? Are you choosing sensors based on the degradation mechanisms that you're trying to detect? Or are you just trying to get a bunch of data in and see what comes out of the spaghetti bowl, right? A famous saying, and I don't remember who said it, but a famous saying is, data with no plan is useless. So make sure you're choosing your sensors wisely and not, hey, we need to just throw these sensors on here and see what comes in. Do you have a fallback plan if a sensor fails? For example, you go out and you put sensors all over your plant, and this could be in nuclear, it could be in fossil, it could be in hydro. If a sensor fails, what's your plan, right? Does someone from your maintenance group, from your monitoring program, go out and work on the sensor? Does your sensor get put into the normal workflow? What is your backup plan for that data from your sensor? And then also wired or wireless. So when we're talking wired or wireless sensors, 99% of the time we're thinking data flow, but we're not thinking power. So for example, if we install a sensor on a turbine bearing and we install, let's say we install a wired sensor and we hook it up to a lighting panel for a power supply. And then we have a loop event, loss of offsite power. That sensor will no longer be powered because your lighting panels all go away. Now your turbine's rolling down and you have no way to monitor it. So we really need to put a lot of thought into this, why we choose the sensors, why we choose wired or wireless data, wired or excuse me, where the power is coming from. So that's sensors. let's go to infrastructure. Now, with infrastructure, I'm going to talk about wireless sensors just for a bit because they're related. So with a wireless infrastructure, it's really a trade-off of battery versus data flow and bandwidth. For example, if I have a wireless vibration sensor and I'm throwing a full spectrum every minute, well, no battery on the planet's going to last more than a few hours, maybe. Whereas if I'm pulling 1x and 2x and just max amplitude every 6 hours, and then when it triggers, then it throws a full spectrum, well, now you have months and months of battery power. So think about your battery power. Now, let's talk about sharing infrastructure. So we want an infrastructure that's scalable. And we don't want the M&D program having its own infrastructure, reactor protection having its own infrastructure, operations having, and so on, right? We're looking at a shared infrastructure. And with shared infrastructures and scaling, have you considered a distributed antenna system? There are several EPI products talking about distributed antenna systems, and the best part is they're extremely scalable. And it's done at one box. So if you want to add bandwidth or if you want to add a new frequency range, everything is done at one box. So it's just something to consider. All right, data repository. There are several different types of data repositories out there, and there are several different brands of data repositories out there. So really the three questions are, does your data repository support your planned analysis software? So for example, there's this newfangled data analysis software that we want to implement in our M&D program. Well, does your repository support that analysis software, or do you need some sort of middleware? Second is your data repository scalable? So when I first got to Luminant in 2007, we had, and this wasn't data repository, it was a different repository, but we were limited to 40 gigabytes, and it was a real hassle to increase that repository above 40 gigabytes. And the joke was, well, I have an 80 gigabyte iPad or iPod, I can plug in my iPod and triple our data repository, right? Now that we're going to cloud-based operations more and more, that's easily scalable. And if you're on-prem, just ensure that your data repository is easily scalable. And then the last one is a naming convention for all of your tag names. So do you just have a random mess of letters and numbers for your tag IDs and tag names? Or do you have a naming convention that really supports your hierarchy of what your sensor is really monitoring? So those are the things to consider for a data repository. All right, cybersecurity. And of course, I have a story for this one too. And Joe Regatti's heard this one before. We have a member that bought over 200 sensors with a fixed cybersecurity, I think it was a TLS cybersecurity fixed to the sensor. And then the company changed its cybersecurity plan and TLS was no longer viable. Not only that, but they required individual devices to have their own username and password, or user ID and password, and they had to change that every 3 months. So this person's giant box of brand new sensors became a giant box of brand new paperweights because he wasn't allowed to use it in his utility. So is your cybersecurity plan malleable? And does your cybersecurity plan detect manipulated data? Right? You may have data coming in, but one of the scares is someone manipulating your data. And we've all seen cyber attacks with manipulated data. And the last thing I want to mention about this is, does your cybersecurity plan prevent you from monetizing your M&D program? Right? Just like the story I began with. Great sensors, great new technology, couldn't use them because the cybersecurity plan changed and the sensors couldn't change with the cybersecurity plan. All right, data analytics. This is one of my favorites because there are so many data analytics applications out there. Some are really specific. Some of them do all kinds of great stuff. So the first one is, does your analytics platform cover long and short-term degradation mechanisms? This really comes from your goals of your M&D program. So for example, if I'm just looking for long-term degradation, degradation that occurs over a month or 2-month period, then advanced pattern recognition may be okay for the only tool in my toolbox. But if I'm looking to cover long-term, short-term degradation mechanisms, maybe I'm looking to cover steam and water losses in my steam cycle, we really need to look at what tools we need in our toolbox and not just rely on one. So I took care of the second cloud. Third, do you have a written and practiced alarm philosophy? So I always preach ANSI ISA 18.2, the alarm management lifecycle. It's really important that your alarms and your alerts are actionable, right? We don't want an alert to come in when, on Saturday night, when your operators are doing weekly pump swaps. We don't want an alert to come in when a plant is cycling a planned cycle, and now we get a bunch of alarms in that we have to acknowledge or work through when it was a planned event, right? We want everything to be actionable. All right, the decision-making process. I'm going to spend a lot of time in the next two in decision-making process and workflow, because what we see a lot is, and I'm sure this affects you as well, is when you get an alarm or an alert and it's related to the reliability of your equipment, we write an email or we just throw it over the fence to engineering or to maintenance and we wait to hear back. That's not really part of the team. Part of the team is engaging in that conversation, having experienced people in your program as well as in maintenance and in operations that can speak to the actions that come from these things. Do you get feedback when, say, a sensor is repaired, or you put in a ticket to have a sensor repaired and the ticket is canceled? Do you know about that, or are you just sitting around and waiting for something to happen, right? Really, we want to be part of the team. Do you know who to contact for a short-term failure mode? For example, if we get a failure on, let's say, Friday night, we are seeing the beginning indications of a failure. Do we simply email the engineer who's responsible for the equipment, the component engineer, or even the system engineer, and then wait for them to get the email on Monday morning? Or do we have an action plan for someone to call, someone to contact for a short-term failure mode? And lastly, do you call the control room? Do you enter work requests, right? I work with several utilities that aren't allowed to do either one because we'll go back to the first cloud. They're not part of the team. So really consider who knows the most about the operating condition of the plant right now, your operators in your control room. And are you allowed to enter work requests, or should you enter work requests and get the information back from those work requests in a quick manner? Right. The seventh one is workflow. So are you informed when a component or a sensor is repaired? We already covered that. The second cloud is, are you part of the work planning process? And this comes from replacing time-based with condition-based maintenance. So let's say, for example, you're working on Alpha Train safety system, and you push an overhaul to the next outage because you're not seeing any indications of a failure. Then halfway through the cycle, you're starting to get indications of a failure. Where does that go in a planning process? Do you take a very short maintenance outage? Do you could be planning your Bravo train maintenance, but now you have an Alpha train component that needs maintenance. How do you work with that? And then lastly, are you informed when a work request or a work order is canceled? That's one of the biggest complaints that we get from our M&D programs is they put in a work request or a work order, it gets canceled by an engineer who has not contacted the M&D program, and the M&D program never contacted the engineer. So the engineer thinks, well, we don't need that sensor. It's not critical. It gets canceled, and your M&D program is never notified. So there's a big disconnect between your planning group, your engineering group, your maintenance group, and your monitoring program in a lot of places that we've seen. And then the +1 business. There are processes, there are procedures, there are action plans in every business. There are action plans, processes, procedures in your control room, in maintenance. Why not in your M&D program? Do you advertise internally? This came from several M&D programs being either decimated or wiped clean from a reduction in force, a reduction in workforce, because those in your senior leadership team really didn't know the value that your M&D program is bringing to the company. So do you put a monetary value on your catches, your fines, or any actions that come out of your M&D program? And then how do you advertise that internally so that your senior leadership team is aware of what you're doing in an M&D program? And then the third cloud, again, is monetary value to catches, fines, or assists. EPRI has a few products that can help you determine what those monetary values are. All right, so those are the 7 focus areas and the 1 business area of an M&D program. About halfway through, now we're going to shift gears to a report that is coming out in stages this year called the Monitoring Diagnostics Program Best Practices Technical Report. And really what we're looking for this is, we're not looking at, okay, what sensors do you add? What degradation mechanisms and failure modes are you looking at? This report is really for the person or the manager or the leader who is running the M&D program. And it helps him or her really look at, how do I build it? How do I run it? And how do I maintain it? So we're going to talk about managing the program, the architect first strategy, which came from John Petriccioni from Exelon. He's the one that coined that term. So I stole it shamelessly, but I always give him credit whenever I say it, architect first. Model development and management, over-reliance on APR tools. And we're going to talk a lot about that one. Alarm and alert management, issue and case management, and then performance monitoring. So let's get into this. Managing the program. Does your M&D program support the corporate vision? And really what I mean by that is, do you have the same vision as what your senior leadership, are you aligned? It's a lot easier to get senior leadership support that way. So do you run steering committees? Do you assign monetary values to catches and assists and other business items? So this is going to be one of the 7 chapters that are going to be in this tech report. Another chapter is architect first. So we already spoke about, please don't start with sensors. Start with the end in mind and work backwards. And that's exactly what this section is talking about, right? Sensor selection in accordance with the continuous online monitoring quick guide philosophy, which is you look at what you want to do with the data. So let's say, for example, we're eliminating time-based maintenance and converting to condition-based maintenance. Are you looking at the right degradation mechanisms and failure modes? What are the severities of those degradation mechanisms and failure modes? Do you have the right sensor detectability? Certain sensors can detect certain failure modes better than others. And then look at the task we're trying to replace, right? What is the task effectiveness? And you combine all those 3 to really get a look at what sensors we need, what kind of data we need, and what we're going to do with the data. The next one is model development and management. And again, it comes right down to specific failure modes. So are you looking at model automation, right? Component condition, plant performance, comparable equipment models. Are you looking at continuous improvement? And we can't just focus on false positives. We have to look at false negatives as well. Is there a way to detect false negatives? Over-reliance on APR tools. This one is a big one for me because we always see M&D programs just relying on that one simple APR tool. If all you're looking at is long-term degradation, that's just fine. But if you're looking at long-term, short-term efficiency and all the other things that I mentioned, you really need more tools in your toolbox other than one APR system. And we're releasing a white paper on this very subject here the next couple of weeks. And it's all part of this best practices document being an agile document. So as we finish these sections, we're going to be releasing these sections. So the first section is going to be over-reliance on APR tools, and it's already been tech reviewed, and it's going through the process for publication right now. And another 2 to 3 weeks, it should be out. So watch for that to come out. Alarm and alert management, we already talked about this, but I'll give you a few more examples of what I've seen for alarm and alert management that really didn't belong in alarm and alert management and what we did about it. So we had a three-tiered system for what's in front of the screen. So things that your analysts are working with right now are on the screen right in front of them. Things that they don't really work with, maybe on the side screen, minimized, but usually your analysts are really good at juggling that sort of thing. What we don't find is, what are you using the screens on the wall to do? Are they really there for show? And if the answer is yes, we've seen that before. Or are we taking what we had in our alarming system and moving up to a tier 3, so moving it up to the back wall? For example, we created a dashboard, a big dashboard of all of our critical equipment and whether or not that equipment is running or not. And if one of them trips, we get an alert on the dashboard where we can see it had an audible and a visual alert, and it was up on the dashboard, so it didn't clutter our screen right in front of us. So while we're trying to figure out why the component tripped, or if a component's about to trip, we're not taking that space up with, yes, the component tripped. We already know that it's on the board. Now we're trying to figure out why. So really, I stress ANSI ISA 18.2 is a great document. Pay close attention to the alarm management lifecycle. Issue and case management. Now, this is really specifically for Prism, since Prism is such a popular APR system. A lot of people use Smart Signal. There's Sure Senses out there and a few more. But we're looking at some issue and case management specific to Prism, since they're really a one-off in how they handle their cases. So we're going to be giving some guidance on, how to set up your cases, how to manage your cases, and when to move through all of your hierarchy of cases. The last one is performance monitoring. Are you running your program in accordance with industry best practices? So EPRI and a lot of other people have some really great guidance on best practices in your center, but let's look at maybe outside the industry as well. So, we contacted John Deere. They have an outstanding M&D. So that's a great way to really take a look at what other people are doing and bringing that into the M&D program. In fact, we have our fleet-wide monitoring interest group meeting, which everyone on here is more than welcome to attend. It's going to be the week of July 12th through 16th. And one of the speakers that we have is a friend of mine who's the chief technology officer, the chief analytics officer for a company called HMS. They're a medical software company. So he's going to show us what they're doing in analytics and diagnostics. All right, and lastly, other items related to M&D programs. So just want to make sure. I heard a funny sound. Can everyone still hear me?
Yes.
We hear you.
Yes. Okay, good. I maybe someone was trying to call me on WebEx or something. Okay. Anyway, so M&D program extras. So let's talk about these 4 things. Agile development. This product is being developed using agile product development. So what does that mean? That means as we get sections done, we bring them to you instead of you having to wait a year and a half for us to complete the report, because we understand that you need this stuff now. So we're trying to bring it to you, a great quality product as they're being done. EPRI Tech App. So EPRI is providing a limited M&D program assistance on a first-come, first-served basis. Now, this will be outside of your member agreement, the standard member agreement. But really what we're putting this together to do is to help you, the member or the customer, implement EPRI guidance. So who better to do that than the people who developed it? So we're working with a few utilities on, mostly right now, we're working with how to get started, where to start, how to, gradually become the great M&D programs that most of you already have. So that's another service that EPRI is starting to offer. Continuous online monitoring, quick guides, and preventive maintenance basis database. So if you're not aware, pmbd.epri.com has what's called the sensor module. And what the sensor module does is it allows you to do what-if analysis on, okay, I have these sensors, I want to detect these degradation modes or degradation mechanisms and failure modes. What is the outcome? Which sensors should I install next? Which has the most value? And by value, I don't mean monetary value. I mean value to your M&D program, right? You're going to find the highest detectable sensors with the most severe failure modes and the most effective maintenance tasks. So that's what value is, not monetary value. And lastly, we just released a brand new Lambda software in December. So it's a long-term capital asset management software found at lambda.epri.com. And it's to help you with your large capital assets. And this was, the predecessor to this was ILCM, which was developed in partnership with our friends over at EDF. We really came together and developed a great product. What we did was we made it more scalable, put a brand new user interface on it, and we're slowly bringing more and more user functionality to that software. So pmbd.epri.com, lambda.epri.com are two great places for information. Go to the EPRI Member Center and search for COLM Quick Guide. And we have 22 right now. We're releasing 4 more this year. And it's all great stuff for our members. And that's it. I don't know how much time we have for questions.
Thank you very much, Michael. We have a bit more than 10 minutes for questions, so I would like to encourage everybody to raise your hands or write in the chat that you would like to ask a question. And while waiting for your question, I would like to ask a question. And Michael, I mean, what is really the definition? I mean, at first I was thinking, okay, monitoring in diagnostic center, it's all about gathering a lot of different signals to sort of one platform, one place. But now you want to redefine it and say monitoring and diagnostics program. So how would you define monitoring and diagnostics?
So I really don't separate the two, right? Because we have a lot of utilities where they're one single unit utility or one single plant utility. So the term center is usually used for a central facility monitoring several different utilities. But a single unit site or a single site, they're normally not going to have that off-site presence like a monitoring center. So a monitoring program can exist in a monitoring center, but not all programs will have monitoring centers. Does that make any sense?
Yeah, but I'm thinking a center could also be to collect the information from different parts of the plant to one center. So sort of creating like a fruit basket rather than comparing a bunch of bananas.
Yep, I see what you mean. Yep, but the reason I went with program was because center here usually indicates one place bringing a lot of one place from multiple utilities. But you're absolutely right. I like your analogy with putting all the fruit in one basket.
Any other questions? Otherwise, I would like to hand over the word to Martin and the remark that Michael made on labeling. Martin, do you want to say something about the RDS project?
I can do that, but I also wanted to ask Michael a little bit about it, and I can mention some of that afterwards, maybe. You were naming here the tag naming convention. It's important as one of many things here. Based on your experience working with different utilities and so forth, are there any, could you elaborate a little bit on your perspective on that? Or because that's an issue we've met in several projects, both in Norway and Sweden, the difficulty when you have old legacy systems and so forth, and which are using different naming conventions and those kinds of things.
So it's really difficult and it's a lot of work, right? And we all know that, and really, what is the benefit of going back through 30,000 pi tags and renaming them? A lot of times it's not. So in your old legacy systems, for example, plants that were built in the 70s and early 80s, they had the old letter number naming convention. So 12 alpha 24 is your tag. So 12 is the system, alpha is the train, and it's the 24th tag we made that day. So it really doesn't make a lot of sense. But then in the description, sometimes you see it's usually in the later historians where you see system or unit, system, component, subcomponent, number, and so on. And everybody has the same thing. So if I look at a tag description, I can tell exactly what the sensor is, where it is, and what it does. So really, it's up to you whether you want to spend the time to go through and rename all of your sensors, or just what I've seen some people do, or some utilities do, is you have 4 hours every month or so where you pick a system and then you go through the naming convention. So maybe over the course of 2 to 3 years, now you have your naming convention set. But it takes a long time to go through that. But if you're starting out with a good naming convention, then the job is done for you.
Thank you, Michael. This is an issue that we've been doing a lot of work on in Norway, especially, and also in Sweden, with developing the naming conventions, those kinds of things. We've been doing a lot of work with the RDS standard, or the ISO IEC 81346. Which has a lot of properties we need going forward, merging different systems into one single platform so we can see across the silos and across different expertise levels and engineering disciplines and so forth as well. So just a little commercial for that standard here as well is interesting for anybody interested in that topic. Any other questions out there or comments for Michael? If not, then I think, Monica, we've had 2 fantastic presentations. Thank you a lot, Michael, and we'll go to break a little bit early, and we'll be back at 15:40 Central European time for those in other time zones. And we can go get ourselves a cup of coffee or something else.
Okay. Yes. So see you again at 20 minutes to 4 CET. Welcome back from the break, everybody. It's time to move on in the program, and I would like to welcome Joe Regatti from Dominion. Please, Joe.
Good afternoon. Let me get my presentation up. Well, hello. So thanks for the opportunity to discuss where we are with Monitoring and Diagnostics Center. And I'm going to include a little bit about our innovation initiative, since that is what drove us to begin the monitoring diagnostic adventure. But first, a little bit about myself. I have 43 years of nuclear experience. I've worked as a reactor operator, an instrumentation technician, training instructor for instrumentation, a supervisor, a training manager. I worked as a fleet integration manager when the facility that I was working at was purchased by Dominion Energy. I've worked as a maintenance manager, an engineering manager, and my current position is manager of nuclear technology projects. My focus is the integration of new technologies into our facilities to make ourselves more efficient and to help reduce our megawatt per hour cost. The main focus of my presentation is going to be where we are in our M&D Center adventure, and a number of the things that Michael talked about I will discuss. I did want to give a brief discussion about who we are as a utility. Dominion Energy is headquartered in Richmond, Virginia. We operate in 16 states with nearly 7 million customers and 27,000 megawatts of operating capacity. We cover natural gas, hydro, coal, pump storage, solar. We're building a new offshore wind farm off the coast of Maryland, Virginia. We have a number of nuclear units. We have 7 pressurized water reactors. We have 5 3-loop Westinghouse plants. We have 1 4-loop Westinghouse plant, and we have 1 combustion engineering 2 steam generator plant. All are approved for a 60-year lifetime for license renewal. And for the 4 nuclear units in Virginia, Surrey, and North Anna, they are currently pursuing subsequent license renewal to get them to 80 years. And that is going to require us to do a digital transformation. We're looking at implementing digital controls for both the safety and non-safety systems, as well as upgrading equipment within the power plant to allow us to get to an 80-year life. So how did we start? Our adventure began as part of our organizational innovation. The fossil side of our house was making significant changes in the design of their plants and shifting to digital control systems. And they found that they had a lot of data that they weren't doing anything with. So they started with using Pi as a data historian, built a number of models, found that they could monitor the plant, but it really wasn't getting them what they needed. So they started to look for advanced pattern recognition tools that would allow them to better predict performance, because they needed to reduce down the number of staff. They needed to try to drive costs downward and make us more efficient. And while they were looking at that, nuclear was also considering how could we use the vast amount of data that we had recorded for 40 years to help us understand how to predict our performance better. And so as we began this, we found inspiration from this particular quote by Jeff Bezos. There is no alternative to digital transformation. Visionary companies will carve out new strategic options for themselves. Those that don't adapt will fail. And we really believe that. There is an enormous amount of work that can be done to improve what we do using digital technologies to help us make a transformation. We can't survive on the analog world that we had before. And so we're working to make that transition. So how did we start? We built ourselves a specification. Our fossil folks and nuclear folks, we got together and we decided what it was that we were looking for. There are a number of companies that have created advanced pattern recognition software tools, and we weren't sure which one we were going to go with. So we created a specification for what we wanted. And then we put it out to a bunch of companies and asked them to make a presentation to us on how they would meet our needs. We selected 4, and over a 5-month period, they came and made presentations to us about their software tools, how their software tool would work. And I tell you, there is such a wide variety of capability out there. There are companies that wish to do everything for you at an enormous cost, but they will monitor all your equipment. They'll tell you what's going on. They'll use their tools, but it's all their stuff. And we were concerned about who owned the data and who owned the results. And really, we wanted to be part and parcel. And for nuclear, it's very important that we own our data. So we did not go in that direction. We chose a company that we felt provided us a set of tools that we could use and work with. And we made some very important decisions about how we were going to run our M&D center. As Michael talked about, we decided that our M&D center was going to be one center for all our facilities. We felt that sharing capability across our entire organization was going to be important. And so the same location houses APR tools for our fossil units, our solar units, our wind units, and all our nuclear units. They work together, they share experiences, they share knowledge and support. And for where we are right now, that is working very well for us. The software we selected is Expert Microsystems SureSense. It does a statistical correlation. We decided that we would start with the data we already had. The fossil units, because they made a transition to digital, had a lot of information that was already available. For the nuclear units, we had over the years put in analog to digital converters. It had a lot of data that went to our plant process computer, and system engineers and component engineers use that data to monitor the plant, but it was all done through Excel spreadsheets and done manually and very, very long periodicities. Once a week, they would go and gather data. They couldn't possibly look at data 24/7. And that was really what we sold the organization on. The ability of the M&D Center to be able to look at and evaluate data 24 hours a day, 7 days a week. That doesn't mean that my M&D Center is manned that way. We determined that we would not do that because our goal is not the identification of the immediate issue. Our goal is to identify plant degradation. We want to be able to make prediction on the performance of equipment long before it fails. Be able to give the plant guidance to say, you need to go out and look at this component. You need to go out and do some repairs and give them time to be able to order parts, schedule, and plan. So you avoid the expediting costs, the overtime costs, all the extra things, and the unplanned shutdowns because you've been able to make predictions about equipment. So SureSense seemed to fit the bill for us. It's relatively straightforward system. You collect data around a component or system. We build a model. The model really just consists of all the points we determined have potential impact on that component or system. The SureSense program goes in and looks at and determines which of those sensors actually have correlation. They are able to shift and change along with each other, so they have relationship. And then the system, using mathematical formulas, makes a decision about how they interrelate one to the other, creates an alarm value, and looks at the difference between the observed and the predicted. It's not a perfect science, but it gives us a better way to predict performance than the tools that we were using. So we have begun our adventure. So where are we? 1 second. So we began most of our work with the fossil facilities. They were the first up, first able to get data. We found very early on in the process that there was a great deal of difficulty with getting the data historians to pass data to SureSense. We don't have a single common data historian. A number of our fossil facilities have PI. That's good because SureSense has a direct PI data transfer. However, there are a number of our facilities that have older data historians, and there isn't very much expertise in making those transitions. So we had to write programs to be able to make those data transitions. I think it's very important that if you go on this adventure that you look at what your data infrastructure is. We spent the first 7 or 8 months building models for fossil facilities. Currently, we have all of our baseload fossil facilities covered. They have models that are in operation. We have been able to identify temperature issues, bearing issues, level conditions that needed repair. We have been able to save the company time and money by being able to identify failures before they occur in our fossil facility. About 3 months ago, we began the effort to make the transition of our nuclear facilities. I've hired 2 individuals to build models and to begin the tuning. We may eventually expand to 4, but right now 2 seems to be meeting our requirement. Again, we ran into some additional problems with getting data. For the nuclear units, all of our data historians are within the firewall. And so getting the data out and in a usable form to get into SureSense has presented a number of problems. And it doesn't help that for each of our nuclear units, we have a different historian. We have PI, we have eDNA, we have R-time. And so for each one, we need to have a software transition. We selected Surrey to be our first nuclear unit. We have successfully made the transition to be able to get data to tune our models. We expect in the next 3 weeks or so to have live data so that we'll be able to test our models against live data and give us the ability to make prediction. It has been a somewhat of a slow process. So we'll do our initial rollout for Surrey at the end of the spring after the outage season. Like Michael discussed, we did need to think carefully about how we were going to interface to the plant and how they were going to work with us. And since we decided that our role is to look at degradation, what we have, our methodology, at least as it stands right now, is that the M&D Center will monitor components. When they identify that there is an issue, there will be a contact point at the station. We will send them the information on the alarm that we have identified and what conditions we think may be associated. Because we're outside of the firewall, before any action on the station can be taken, the information we're passing along has to be validated. It's the choice that we made by operating outside the firewall. The system engineer, component engineer will validate the information that we're given. If they identify that it's a condition that needs to be addressed, they'll write a condition report, it'll go into their corrective action system, work will get scheduled and planned, and we'll move forward in that manner. It certainly makes it a relatively smooth process. And we made the decision that we would be looking for long-term degradation and not immediate issues because we're not set up for that. As I said, Surrey is going to be our initial rollout, Surrey 1, then Surrey 2, and we expect that to occur in the spring of this year. As I said, we had significant challenges with IT infrastructure development. The firewall caused us a number of issues. Corporate hardware, getting the servers in place, all the different pieces to make it work. The one nice thing about SureSense is that the data processing can actually occur on a PC. They allow us to have an unlimited number of licenses, so we're able to have people work from home and gather data. The IT firewall, that gave us difficulties as I described. The last part, is trying to find people that understand plant historians so that we're able to make the transition of data from one to the other. Even the vendors, to some degree, while helpful, they're not doing the software programming necessarily to make the transition. They'll tell you what their software does, but you have to write the code to be able to make it move into SureSense. Where are we going? As I said, our goal is to figure out ways to reduce cost. As Michael sort of described, we have decided that our first step would be to integrate the data that we have. So we're starting out with our plant process computer data. Once we have that working and we have data that we can begin to use, we'll start to use the data that's in our ESOMs or the plant logs. PEOs and operators on the boards take logs on instrumentation that doesn't go to the plant process computer. And so we can gather that information that'll help make our models more predictive. And of course, then the next step is to really identify what additional sensors would make sense to help us reduce our preventive maintenance and make our predictive model better. And so we'll use the column guides we've already started to identify where do we have differences between what EPRI suggests and what we actually have, and then how can we install sensors to make up for that difference and do it in the most cost-effective manner. That's a beginning process. And the one thing I didn't mention, and I know it's coming up here pretty quick, we do not currently have Wi-Fi in the power block, but we have approved funding to implement Wi-Fi in the power block. And so over the next 18 months, we'll be putting Wi-Fi in our plants, and then that'll give us the ability to add additional sensors. So what do we see? We see a reduction in cost because we're able to plan activities. We'll see a reduction in preventive maintenance because we'll be doing shifting to predictive on anything that we can. And currently, as I described, our system engineers do a lot of manual trending, a lot of pushing data to Excel spreadsheets and then making reports. We'll be able to take over that through the SureSense plant health software and be able to provide them information on their system so they don't have to do that manual data manipulation any longer. As I said, our plan is to expand to our entire nuclear fleet. So Surrey is up first, North Anna second. We expect that once we've solved the data issue, North Anna will be towards the end of summer. And then Millstone, which is the 4-loop and the 2-loop combustion engineering plants, we'll finish up them with their initial models by the end of this year. And then we will begin the effort of identifying additional sensors and expanding our capability. So as I said, for future expansion, wireless data communication is pretty key. We'll be expanding that to all sites, and that'll help us with our sensors and help us do that in a cost-effective manner. Where, like I said, getting additional outside data. We're working on implementing a data lake to allow us to see other data streams, such as surveillance results, any kind of IS surveillance testing data, no matter what it is, and then sensor coverage. The fossil units are currently looking at vibration sensors to add to equipment, and we're looking to do that as a common thing across our entire fleet once we select a vibration sensor type and company. Motor current is another area that we're currently looking at, and we want to integrate all those sensors into the data historian. All right, so before I talk about any other innovations. Does anybody have any questions?
I think it sounds like an interesting solution to have the system sort of outside of the firewall. And you mentioned that only verified information is sort of brought forward. Could you elaborate on that?
Because of the cybersecurity requirements, the way that we have determined to implement them, when data goes outside the firewall, there is the potential that it could get hacked. So our resolution to that was the M&D Center will evaluate the data that it has, and then if it identifies a potential issue, we'll transfer that information to the station, and they can validate it inside the firewall. So they'll validate the information that we have from inside the firewall, and everything's in alignment, then they can move forward and take plant action. But we're committed to not taking any plant action based on unvalidated data.
So is it done by plant experts or control room staff or?
Done by in-plant experts, the system and component engineering department.
And then I was also wondering, you mentioned that you're about to install wireless. What kind of technology are you using?
That is beyond my knowledge.
Okay.
I have a question here. Just to everybody, you're more than welcome to just write your question in the chat as well, or raise your hands. You were talking here, Joseph, about the working with existing vendors on getting the data out and so forth, and the collaboration there that they are willing to help, but you often end up writing a lot of the code yourself. Could you I think that this is a tricky part for many companies. That process there it's one of the many small steps we have to take. Could you elaborate a little more on your experiences there, do's, don'ts, stuff like that?
So without identifying the company or the companies, we have found that first step, find the expertise early on in your trying to deal with the data. In one particular case, the company is very willing to work with us to identify how their data is constructed and to give us the information about how to interpret it. But to get it into the program, you're going to have to write C+ code to make that transition. They're not willing to do that, so we have to do it. And so that creates its own set of problems, and finding the resources to do that and make sure that it works, and just it takes time, and you've got to recognize that it's going to take some time.
Are there any other questions? Okay, maybe Joe, if you want to elaborate on your other innovations, and while
Sure.
Joe is speaking, everybody's more than welcome to write additional questions in the chat.
All right, so just a number of different things that we are currently working on within our innovation initiative. We have been working with virtual reality and augmented reality. We have a very good success story with virtual reality with a tool that EPRI helped build, and that was for a plant Terry turbine. They built a virtual reality model for a Terry turbine. Our technicians at Surrey needed to do a overhaul of that machine, and so they used the virtual reality system to train themselves on how to take it apart and put it back together again. This was their first time doing that overhaul. It hadn't been done in 10 years. And those technicians didn't write the first time. It isn't a simple operation, but they themselves credited their practice in virtual reality to supporting their capability to do the job and to do it efficiently. So I see that as a big win. Virtual reality tools are expensive to build. They can be best done when they're done cooperatively with others, but they are an option that we should be looking for. We can help each other in producing them, and they become good tools for helping technicians in the field. And if you think about our future with less staff, there's going to be less experience, and we need to have tools to help people in the field do the job right. So having virtual reality tools are going to help. Let me speak a little bit about electronic work package. We made a transition this past year to electronic work package. Now we have Maximo that actually develops the work package. The electronic work package I'm describing here is having a Microsoft computer pad that can go out in the field with the technician, and rather than having paper, everything is done digitally. That transition, it's taking time because you have to teach them how to use the digital device to do work orders, but it's beginning to take hold. And what we're really expecting is that once we have Wi-Fi in the field and we have electronic work package in the field, we'll be better able to track work performance. If a person in the field has difficulty on the job they're doing, they'll be able to contact someone to get help. And if we take it right to the very edge, the tool that they have has a camera, and we'll be able to take videos and transition them to experts so they can help identify the problem and help fix it before it becomes a significant problem. So we see that as a nice expansion of the capability of doing work in the field. And of course, the follow-on to that is electronic procedure. We don't have that yet. We're currently working to develop that. But we believe that there's a great value in having all the surveillance procedures that we do in digital format. And that would allow us to do data trending associated with it. It would allow us to track it and trend it better. And it can be done in such a way that it avoids a number of human performance errors that could occur today with the handwritten methodology that we're following. And then the last one I would wish to speak a little bit about is drone technology. There are a number of different ones here that you can see. We've used the Helios drone, that's the cage drone, inside of our containment. We've been very successful in identifying leaks, reducing dose rate, going out and doing valve lineup verifications with it. We have done a condenser inspection. We've done a number of implant monitoring inspections successfully in reducing the cost associated with those, and especially a reduction in the dose that people have received. We have used a number of crawler drones. Last year, we did a isophase bus duct inspection using a crawler drone. First time we ever did that evolution. Normally, we build scaffolding. The scaffolding is in the neighborhood of $750,000 to build a scaffold on the isophase bus duct. We did the entire job for 1/10 of the cost. Significant savings, and we got a better inspection. We were able to correct some long-standing issues, and we ended up doing a much better job cleaning the isophase bus duct. Expect a much better reliability out of it. The picture in the bottom left-hand corner, that's a crawler drone that we use inside our service water piping, underground piping inspections. We've been doing that for a number of years. We're also working with a crawler drone that will actually do UT, specialized UT. So we're finding a lot of benefit associated with drones and drone capability. We have started to use submersible drones. There is a submersible drone that has sonar, high definition cameras, and has been very successfully used in intake structure at Millstone Station. We'll be doing some discharge piping inspections next year with it. And what that really saves is diver time. We spend an enormous amount of resource on putting divers in the water. So the submersible drone has really shown itself to have some real value for us. And then the last one that I'll talk about is Spot. That's the Boston Dynamics robot. We are currently working to develop a project associated with Spot. Spot has the capability to do automated rounds. It can carry an arm that will open and close doors. It has 8 cameras on it. It can carry a high definition camera and carry infrared and LiDAR as well. And so we're looking to for a project to have it do our ISTOC, the dry cask storage walk downs. Instead of having a person do that every 4 hours, have Spot do it. That will save us time and resources. And it will be always the same, so that will be good as well. We're also looking for Spot to do the inspection as we do the head lift, because Spot has good cameras and can be relatively close to the reactor head without any issues. That will save dose for the normal inspection that we have to do. We tried doing it with a drone, but unfortunately, drone battery life is too short, about 15 minutes. Spot's battery life is 90 minutes, which will be more than sufficient to do the inspection we need as we lift the head or replace the head. So those are the things that we're doing on the innovation side of the house. Anybody has any questions on that?
Really interesting project. And do we have a question from Marta? Marta, do you want to read your question?
If not, maybe. Okay, Marta had a question.
Yeah, it's okay.
What?
Hello?
Hello.
Yeah, it worked at last. Yeah, I had a question at the beginning of the presentation. I have understood that the idea was to have one M&D center for all the facilities, so wind plants, nuclear, etc. And I wanted to know, how do you deal with different IoT protocols, data transmissions, data infrastructures, etc. Because from my experience in EDF, only for the nuclear fleet is complicated enough, and we share the same data model, the same infrastructure, etc. And in wind farms, so as far as I know, there are a lot of systems that are owned by the providers of wind turbines. So we are not able to have all that we want.
We decided that we would do the centralized M&D center mostly for the people who are doing the running of it and building of the models. We felt that there was a lot of experience to be gained from supporting each other. And actually, it's worked out that way. My 2 individuals built models for one of the fossil facilities. It's how they got trained, actually. You're right in that, each vendor of whatever you have to work with to get their data. A number of our solar facilities were built by diverse vendors, and some of them had their own data historians, and there's no consistency. So we have to work with each one to get at the data and get the data translated. But so far, all the companies have been supportive. Some have required some additional payment, but we've been able to negotiate the price on their support. And for the wind generation, because we're building a wind farm, that was part of the contract that we put together, was to be able to get the data and get the data put in Pi, and Pi makes an easy transfer to our M&D center.
Okay, thank you.
Thank you, Joe. Any other questions to Joe? Okay, so thank you very much, Joe. And I wish that I was working at Dominion when I see all your interesting projects.
Oh, thanks.
We have a last minute question here by Arto Laikari.
Okay, hello. My name is Arto Laikari. I work in the Technical Research Center of Finland. And I was then thinking, because you mentioned that you are then going to adopt the wireless into use in the all the fleet, so including the nuclear. So do you think that getting the acceptance then for adopting the wireless technologies into use in the NPPs, was it an easy process, or did you confront some resistance that wireless is not possible, or it's a technology that will be then hard to be inside in the system with the legacy systems that are already there?
Certainly as part of the design process, we had to overcome some of the conceptions associated with the implementation of Wi-Fi. But we went through and we did the studies of the plant to look at what frequencies are already in use. There was already a lot of data about Wi-Fi and its potential impact on other electronics. We identified what areas would be at risk, and they're isolated. So we did not find some significant pushback on the implementation.
Okay, that sounds nice, because then at least sometimes it feels that then there is this let's say fear about the interference for the old systems, that then in a way it's better to see that somebody else does the solution first, or then in a way it's this egg and chicken problem that nobody dares to do it, then and then they are waiting that somebody else is then adopting it. So it's good that there will come the good examples that they are into use, so then it will encourage also the other plants to then take them into use.
And EPRI has been very helpful in helping us understand the potential impacts. They did studies. We used their data. We used data from other facilities that have already implemented Wi-Fi. So it wasn't as hard as we thought it might be.
Okay, thank you. That was a nice news then. I guess Monica is muted.
Sorry. Thank you again, Joe.
Yeah,
and
I will say, I was going to say one other thing is that having a wireless technology, whichever one you pick, it aids all of these things. One of the interesting things about SPOT is that if there is Wi-Fi in existence, it can walk just about anywhere in the plant and know where it's been. A number of drones use Wi-Fi as a way of communicating. The different ways to have communication to technicians in the field to help them do their job. It's hugely advantageous. So I am very excited about our transition to that. And, it should help us become very much more efficient in our implementation of work.
I really think that the US plants are forerunners when it comes to installing wireless in the plants.
All right.
So thank you. And let's move a bit north in North America and across the border to Canada. Vincent Roy from Hydro-Quebec. Most welcome.
Yes. Hello. Let me just get my presentation up and running. Can everybody see the presentation?
Yeah, it looks great. Thanks.
Looks great.
All right. Good. Thanks. Well, first of all, thanks for having us in your conference. We're excited to talk about our project. My name is Vincent Roy. I'm an engineer at Hydro-Quebec Production Division, and I am a member of the CAMP project, which stands for Center for Analysis and Predictive Maintenance, which is Hydro-Quebec's production division MND Center initiative. This is a new initiative for us. We've started working on it in late 2019, and so we're slowly implementing the infrastructures that we need to be able to start running and rolling out our MND Center. My background is more in the dam safety side of the business. I have with me some of my colleagues here are in the conference are more on the turbines, and will do my best to do the presentation and answer some of the questions at the end. So the goal of our presentation today is to tell you a bit about Hydro-Québec, but more precisely what the CAMP project is. And since we are starting off, talk about how we've made justification for the company to say that it is a cost effective project, that there are benefits that are sought out, that we're after. And then we'll describe a bit of the vision that we've laid out in front of us to roll out this MND Center. Contrary to some of the past presentations, we don't have yet much maturity, but we have things that we want to share with you. Maybe just a bit about Hydro-Québec. Hydro-Québec is a producer of hydroelectricity located in the eastern part of Canada. As the name says it, we produce power that is 99% hydroelectric. We are a company that is divided into 3 divisions. There's a production division, a transport, and a distribution division. Hydro-Québec is roughly a 19,000 employee company, and Hydro-Québec production mission is mainly geared towards generating power and also developing new facilities. Its main market is the province of Quebec in Canada, which represents about 85% of our production, although 15% of our power is exported to wholesale markets in northeastern North America. We have here a picture of the Manicouagan 5 hydroelectric complex, which symbolizes a bit Hydro-Québec. Its main piece is the Daniel Johnson Dam, which is a large multiple arch dam, which is 1.3 kilometers in length. And that indicates a bit the scale of some of the generating assets that we are operating. So just to go a bit further, Hydro-Québec is Canada's largest producer of electricity, and we produce roughly about 50% of all hydroelectric power that is generated in Canada. We have generation assets that are the equivalent of $31.4 billion worth. We have an installed capacity of 37 gigawatts. And in order to produce this power, we operate 681 dams. Many of these dams, about 120 of them, are classified as large dams according to the International Organization on Dams. We have 62 generating stations. We operate 28 reservoirs. And since our assets are really distributed over a very wide territory geographically, we have to have a wide network of roads to access these. So we have 2,600 kilometers of roads and quite a number also of bridges. So that's just to get a bit the scale of our company. And getting back a bit to the agenda here, we want to talk about a bit what is our new project, the CAMP project, that we have a cost-effective project. We have benefits that we've identified, that we've translated into monetary value, that we've put into our business case, that have been used to help us bring this project to life. And then we'll share with you a bit of our vision of where we are right now. We're in our first few steps and where we want to go. So it has both short-term and some long-term aspects to it. So what is the camp? Well, Hydro-Quebec in the production division right now, our maintenance strategy is a planned maintenance strategy, essentially. So it's a time-based, so based on different components. There is different frequencies that are specified to do different maintenance tasks. So the company wishes to make a move from the planned to more of a conditional and predictive maintenance strategy, where we're actually following the behavior of our assets and based on these behaviors and deviations from normal behavior to recommend and perform maintenance tasks. So this is where we're, and the whole reason why we're setting up this camp project initiative. Here's our one-pager that describes a bit, and this is what we've been using internally to start not only selling to the upper management, but to all of the employees at Hydro-Quebec, what road we want to go down to. This is our one-pager, and it states essentially that we want to be able to forecast the behavior of our assets in order to do predictive maintenance at the right time. And we aim to do this for quite a number of different assets that are used in the production of electricity. And that ranges from dams, spillways, to generating units, to the auxiliary systems, and eventually to critical infrastructures such as bridges and certain buildings. And what we intend to do here is capitalize on the data that we've been accumulating, whether it be sensory data for on our dams, on our generating units, whether it be maintenance data, operational data, and be able to combine this to give us insights on what is going well and what is going wrong with some of our assets, and combining this with algorithms, machine learning algorithms. We're looking into building some digital twins for certain types of assets, so that we can have, so that we can collaborate with the operational staff to prevent failures, to optimize our maintenance strategies, and also provide tools that will help us in making better diagnostics and asset management, and also at the same time provide reliable data to both our operational and technical expertise staff. Here is just a few of the examples of things we would have liked to have avoided. Some of the things that we're starting to do. As I said, we're really in our first few steps here. So the example we have on the complete right is a monitoring that we've just started to roll out for our Manicouagan 5 hydroelectric dam. We've had monitoring systems in place for quite a few years, but the step we're taking here is actually to, in the loop, add machine learning models that can that have learned from past behavior to predict future and compare that with actual readings to see if there's a deviation. So the image we have here is that for this particular dam, we have heating systems that are located at the base of each arch, and these heating systems are put in there in place to ensure that since it's the very thin arches to limit the the propagation of thermal cracks. So they're indicating whether the heating systems are performing as previously and as predicted. If there's a deviation, then it's not an alarm, it's more of a early warning. That's what we want to put in so that we can actually go in and do maintenance on these systems. So that's sort of the philosophy that we're putting in place for some of the dam safety aspects. The lower image actually is an example of what we would like to avoid. We had a major failure on these. We have a turbine system at a group places called La Sarcelle. It's a bulb type generating unit. It's a completely submerged turbine, we had a major failure because of one of the structural we had structural cracks that developed, when we look back at the vibration data, we can see that this the early signs of the weakness were detectable back in almost a year and a half previous to the major failure. So this is, some of the cases that we would like to avoid. The following slides have to do with a bit of the business case that we put together to justify the implementation of the M&D Center. We've identified that there are a number of benefits. There are monetary benefits, obviously. There are some also non-monetary benefits. The benefits have been further declined into different categories, such as maintaining or controlling our maintenance deficit, the stack of the backlog of all of the tasks that needs to be done, increasing the asset reliability, reducing power outages, making better investments, eliminating systematic maintenance tasks. So going back to our planned task schedule and trying to see which can be cut out of that is either redundant or not necessarily effective, and see how we can replace that with a predictive maintenance strategy. Reduce losses, extend service life is definitely a point. We have assets that are quite old in some instances, that have been in operation for more than 80 years. There have been rehauls that have been, but there are relatively old generating facilities. So that's definitely an issue, how we can prolong their life, and one aspect that is very close to the safety of our operations, certainly in the dam safety field, is improving asset security and risk management. So this is some of the potential benefits that were looked at, and from those we've selected some of those and then translated those into monetary values and laid them out in a timeline for making our business case. So reduced power outages was obviously part of that. Those that were selected and evaluated, improve asset security and risk management. So we put a small star to that because it's really hard to monetize that aspect, but it is very important for the company with regards to our different legal obligations. Reduce losses, eliminate systematic maintenance tasks, make better investments, and as mentioned by some of the other participants, we have a a lot of time people going back and doing analysis, and this analysis takes time. So we want to facilitate this analysis time and recover some of that cost that is associated. So that is pretty much covers, at a high level, how we went about identifying what we wanted to put into our business case, and that has been what initially, a lot of our efforts in the first maybe stages of our M&D center planning, or we did. Another portion of the time was also making sure that we're developing a vision that's not only part of the M&D center, but that's really shared with all of the different stakeholders within the organization, whether they be at the production division level, but also with other divisions. Starting building networks to share information, since we are quite a big company, and expertise is found a bit everywhere. So one of the efforts here is to start developing a bit of an ecosystem where we can share internally on some of the initiatives that are going on, whether they be with the production, the transportation, or the distribution. So putting together a monitoring community. Also, our IT department, knowing that our transport division and production is more and more interested in how to better use the remote monitoring data for helping us in maintenance, has been putting together a strategy to help us monitor even the IT infrastructure. Also, we're quite lucky at Hydro-Quebec. We have a research center, research facility that is located close to Montreal, close to corporate headquarters. And we've actually, as soon as we've put together, or the initiative to the M&D Center, started putting into the portfolio of the research center ideas that would later bring fruits to our M&D Center, in terms of not only being able to do detection of changes in asset behavior, but can we bring that eventually further to prognostics? So telling us what are the potential causes, and how much time we have till we have a degradation, or important degradation, of the behavior. We're also investing in digital twins. So we're starting off these investments for the turbines, and also we have some digital twins that we've been investing in terms of dam safety. We've also in the portfolio investing into imaging technologies that would help us to get different sorts of data on the health of our assets in time, on a time-based scale, and artificial intelligence being essentially a big part of what we're doing at the M&D Center. So we have within the research facility a group that specializes in machine learning, and we are also building partnerships with a center which is based out of Montreal. It's a center for artificial intelligence called the MILA. So this is the ecosystem that we're setting up, which is a bit on the foundation of what we want to lie the M&D Center on. We've been monitoring our dams for quite some time. It's manual data that we have, but we do have a certain number of our more strategic assets that we are monitoring with data acquisition systems. And the move lately was to move these data acquisition systems to a a more company-wide system for ingesting, collecting the data, which is a OSI soft PI system, and that system is also, or that technology is also being used for our turbines. So we're slowly moving over to our common infrastructure, whether depending, irrespective of the type of asset. And this centralized and normalized infrastructure we see as really being able to permit us to lay the foundations of our M&D center on top, so that we can start deploying and rolling out models to follow our assets. Same sort of a strategy here for our generating units. For several years, we've had quite a few points that we follow on our generating units. It's not all of our power units that are that well equipped, but more of our strategic assets have been equipped with a system that gets data from sensors, some calculation, and also states of the equipment. And once again, this is fed into a PI system, and this is what we'll be using as a common base to put on top or to lay our APR technology on top. So this is actually a stage that we are at right now. We've actually we had a request for proposal for an APR system. We've just signed on with a provider, which is called EdaPro, and we are currently implementing the system right now. Talk about a bit maybe about where we see ourselves right now and where we'd want to go further down the road. There's been this pyramid used to indicate a bit the maturity of monitoring, which is in 4 levels. The level 1 is using the already installed sensors and doing an analysis of all of the appropriate failure mechanisms and identifying which ones we want to track and build APR models on. So this is where we're at right now, the level 1, and we've started down that road last year, and we'll roll out in 2021 to over, we want to aim at 22 generating stations. We were doing the same thing with certain dams. We're not using the same APR technology, but it's the same philosophy as a bit as the APR, where we're learning from past data and in order to get a model of the behavior of the asset of the dam. Level 2, where we're like to maybe put our foot a bit into 2021. We're starting to look at and working with partners into more advanced algorithms for the detection of changes in our assets in the dam safety field. We're looking at using state space models to help us, and the learning models are continuously learning models instead of fixed training periods. So we're looking into that technology. We're going to be trying to implement that at the end of the year. And then this is further goals down the road, automating our diagnostics, not only detecting the changes, but potentially identifying what the causes are. And eventually our very long-term goal, the dream, is to go down the road to prognostics, where we could not only identify the potential causes, but indicate how much time we have left before either a failure or an important degradation of the system. So our vision, we've laid it out into 3 phases. The first phase we call operationalization of the monitoring. The second phase, expansion of the monitoring, and phase 3, which is really the long-term mastery of the monitoring. So phase 1 is where we're currently at right now. I'll go over some of the key activities that are going on right now. First key activity is to clean and make sure that our measurement chains, that is the sensors and all of the pieces that are downstream from there, are bringing the right information to our PI system. We're looking at also, we've started to work with our different stakeholders, whether they be the people that are in operations in the field, the people that will be at the center, to develop the processes that will be used to in the operation of the center. We're just as I mentioned a bit earlier, we've just acquired one piece of software, which is an APR based software based by the company by BP Strategies, the EdiPro software. So we're implementing that, and that's the same time putting in all the different tools, checklists, methods that we need to operate the center. We're being accompanied in this process by a consultant to help us out, making sure we're doing the right steps. We're also at the same time, Hydro-Quebec is investing money into a pooling data into a data lake, whether it be maintenance data, whether it be operational data, and so in terms of the M&D Center, also we are a stakeholder in this initiative. So we're another key activity that's going on is developing anomaly detection algorithms. So we've got people other than the APR system that we're putting together. We know of some cases that the APR technology will not cover. So we're working with our research facility and working also with partners in universities to lay out work on this on different use cases that we know that we might not be able to cover with the traditional APR. The assets that are targeted in this first phase, well, there's the generating units, about 22 for 22 power stations. We're aiming also with dams that have also already in place data loggers that we've put in place to extend from our normal manual inspections, either because of strategic considerations or of complexities on site. Another area that we've been investing in for some time is spillways to ensure reliability of spillway operations. We have a project that enables us to, based on the amperage of the motors used to manipulate the spillways, evaluate the safety factors of our spillway gates, and we've been starting to use this in a manual type of setup, but we want to move it over to a automatic mechanism. A lot of our dams are run-of-the-river dams. It means the spillways are operated on quite a regular basis, and for legal obligations, we have to ensure that these safety and legal obligations, we have to ensure that these spillways are quite functional, reliable. So we're developing algorithms to help us identify when these spillways are not in optimal operating condition. So, and these we want to tie into our M&D Center initiatives. Other types of assets that we're looking at eventually down the road is hydro stations. We have quite a bit of hydro stations that we meteorological stations that we operate in order to know what our precipitations, the amount of snow that we have accumulated, and we want to be able to help in the operation of these meteorological stations. We have 2 solar generating stations that are coming online, and since they are quite new, we've requested that when developing and implementing these stations that we can tie them into the M&D Center. So that's the operationalization of the monitoring phase 1, which leads us to the end of 2021. We're going down that road. Things are relatively on track. Phase 2 expansion of the monitoring, where we want to look at new sensor technologies, start using the work that is being done in research facility on digital twins and how that can be integrated into the monitoring aspect. We want to also add more instrumentation. We went down the road of identifying all of our failure mechanisms. We know which sensors actually are there and how they can contribute to certain mechanisms, and then we see that further down the road we'll probably need to add further instrumentation to be able to reduce more of the planned maintenance tasks with predictive maintenance tasks. So that'll be a bit more of the expansion that we'll be doing, or that we would like to do in the second phase. The assets that will be targeted here are going to stations that do not currently have data logger technologies or acquisition technologies, that were either not our first strategic powerhouses. So looking at implementing maybe lighter systems in place, looking at the auxiliary systems, looking at also at dams that don't necessarily have data loggers, and maybe we don't want to put data loggers, but using manual readings and feeding those into the same mechanisms to help us identify changes in behavior. So that's roughly the plan for phase 2, which would be carried out, in between 2022 and 2024. And the long term here is where we would like to further move down the road or up the pyramid, as we saw a bit earlier, from not just only detecting on changes in behavior and doing predictive maintenance, but also helping us identify what are the potential causes, and helping us automatically detect how much time we have. So we're counting on digital twins as being furthermore helping us out in these phases, and using also imaging technology. So that's a bit of our layout of our vision, our road plan. Okay, this is the high level view of our vision and how we want to put it together, pull it out. And this brings us to maybe just a final thoughts here, words. As I mentioned a bit earlier, we're starting to walk down that road. We've managed to sell this project to upper management, and also to the operational staff. So this is, we're in our first phases. We've getting company synergy has been a lot of the work that we've been putting effort into. The change management plan has definitely been quite consuming in time, making sure that we're all aligned properly. Let's just say that there has been an initiative in the past that we tried to start off and probably didn't start off on the right foot. So this is like a second start for us here a bit. And we've put a lot of energy into our change management plan here to make sure that everybody is lined up correctly. And we're seeing the results now that people are buying in, asking a lot more questions, and that's a good sign. So that what we had to offer at this time, maybe at a further time, maybe a year or two down the road, we could share more on our experiences. And I'm up for questions. I'll try my best to answer them. If I don't have the answers, I might pool some of my colleagues that are here online with me, or we'll write them down and try to get back to you later on if we don't have the answer right now. Thank you.
Thank you very much, Vincent. Really interesting to see your strategy. And I would also like to emphasize what you mentioned about getting everybody on board. That's really important to get a successful project. And I would like to ask you, you didn't mention wireless in your presentation. What's your view on that?
Actually, on wireless, we haven't really gone down much that road right now. We do have an initiative, though, that is aimed at looking at the, let's say, the power station of the future, and they are looking at how wireless sensors are coming to play into our, we call it the station, the power station of the future, using also looking at different communication data structures and protocols. I myself wouldn't be able to comment further here, but I know that this is playing out here. That we are investing in looking at how this can contribute to our M&D center and getting the data from the field to the M&D center. I can say maybe a word on my field of expertise is more in the dam safety business, where we're slowly starting to make use of different. They're not wireless. They're more satellite communication technologies to get data from the site, which is very remotely located, and this is the prices are going down. The options are wider and wider, and this is enabling us to add to our portfolio of sites that we can monitor more sites, because these technologies are quite evolving and are enabling us to go in places where we wouldn't be able to go before at a cost that is reasonable.
Thank you, Vincent. We have a question here from Richard Helgren.
Yes.
Richard?
Yes, hey, I actually think there was someone else had a question before me, but I can start. Hey, I'm Richard Helgren. I'm a PhD student at KTH in Stockholm, working with this type of prediction models for dams. So I had a question about how do you plan to handle false positives during the automatic anomaly detection?
Effectively, that's a really good question. Right now, we're using we've just started to roll out for the Manic 5 dam about 80 machine learning models. These machine learning models are essentially linear regression, multiple linear regression models that take into account water levels, they take into account temperature, they take into account irreversible time effects, in the dam instrumentation, there's a lot of potential influences, such as a spider can make a web on one of the instruments, a pendulum, and that'll get it out of whack. So this is definitely a challenge. So we are getting, we started rolling out these models last fall. Large potential, part of the false alarms we're getting are either instrumentation or maintenance staff that is doing things around our instrumentation. So there's a lot of things to work out there. With this type of model, it's definitely quite a bit of a challenge. We're working with a professor from Polytechnique University in Montreal. We're working on state space models that rather than linear regression models are continuously a bit learning. So we're looking more at what is the rate of change of our different factors. What is the acceleration? This can be help us quite a bit. And one of the techniques that he's looking at and that we wish eventually to put in place is using reinforced learning to help us make models that will get better at actually making the difference between the false positives and the false and the true positive. So we can see it's quite a bit of a challenge. Do we have the solutions right now? Not yet. Yeah. I don't know if that answers.
Yeah, I mean, it's always going to be a problem. And if you look at the dam on the picture here, I mean, it probably has quite large temperature variation displacements during the season and so on. Have you done any simulation on your digital twins on how large the actual failure modes are compared to the natural variation?
Well, with this particular dam, yes, we have built a digital twin here. It's been almost close to a 8-year work in progress to get the finite element models to closely follow or to at the actual measurements. And some of the further steps, they were used initially to help us assess some of the weaknesses that we have, but we're looking to taking these models and eventually trying to see if we can implement them into the MND Center and to help us just to, like we mentioned a bit earlier, to see if those can help us out in I would say filtering out the alarms or alerts that we're getting based on what this model would be telling us. So, but that's still some work down the road, So we're essentially just trying to say right now, can we be smarter than having just fixed level alerts and do dynamic alerts? This seems to work out, not everywhere, but it seems to work out. But after that, there will come other challenges to make sure we can filter out the bad from the good.
Okay, thank you. I'm sorry for kidnapping this
no problem.
Workshop for dam questions.
Yeah, good.
So let's just quickly let Yves Laurent ask his question.
Yep.
Yes, sorry, Yves Laurent. Thank you, Vincent, for your presentation, and I wish you to success in this interesting, ambitious project. How many dams do you remote monitor today? And do you analyze the unmade manual readings, dam monitoring measurement in your camp?
We've been monitoring about 30 of our dams that have more of a specific behaviors that are remotely monitored, and that's been for quite some years. We're going back to almost 25, 30 years down that road. The difference here now is that we're putting in the loop these machine learning models to help us try to be a bit to see out of that clutter what are slight changes, and that can bring us to maybe modify our maintenance strategies, change our maintenance strategies. And maintenance in the dam safety field is more inspections, because maintenance covers that whole aspect, whether it's inspection or actually work being done on the dam. So and right now the M&D Center is we've only concentrated on 2 dams, which is the Daniel Johnson Dam that we have here, and another dam which is called the Latuc Dam, that have some particular performance that we're looking at. And one of the further steps that we want to do down the road is that we have a lot of manual inspection readings that we take that are part of our program to do a yearly diagnostic on our dams. And we'd like to be able to help or take our models and build models on the manual data to help us identify bad readings, identify and further identify slight structural changes that could be brought to the diagnostic team. The learning models that we have right now are quite rudimentary. They're linear regression models, but we're looking at more using switching Kalman filter models that are really interesting in ensuring that we can see the changes, the slight changes in the performance of the dam, let's say in displacements and so on. So I don't know if that answers Yves Laurent.
No, that's
question.
Fine. Thank you.
Yeah.
Thank
Okay.
you. That's fine.
So thank you very much to all of you speakers and all of you participants, especially those of you participants that were active and asked questions. I love that. Martin, you want to say something before we say goodbye?
I agree totally with you, Monica, and I think we could go on for a lot longer asking Vincent questions here on their strategy, on his strategy and approach in Hydro-Quebec, but I think we should conclude now, and thank you all, especially to the speakers and to all of the participants, and looking forward to seeing you all again.
Yes, and keep a lookout in your emails for the email with the link to the documentation. So thank you and have a nice morning, day, or evening, wherever you are. Bye-bye.
Bye-bye.